Hi there, welcome to GMT Nurses Health, and today we're learning about calculation in pharmacology. But before we continue, for those of you new to our channel, do well to hit the subscribe button and also hit the notification bell so that whenever we drop awesome educational content, you'll be informed. So let's get started. Now, we're learning about the flow rate, and there's a formula for flow rate. So I actually use drip rate because most tests will actually show you drip rate. So the formula is the drip rate or the flow rate is equals to the total volume of infusion times the drop factor, the total time of infusion, which is usually in minutes. So let's explain this whole formula here. Now, the total volume of infusion is actually the total volume of the infusion to be given as prescribed by the physician. Most of the times for adults, we can see the volume of infusion can be 500 mils, and the total volume is usually in mils. Then we talk about the total time of infusion. This actually has to do with the time frame at which the infusion will be delivered, and is usually calculated in minutes. And the other part is the drop factor. Now, the drop factor depends on if you're giving infusion or you are doing your blood transfusion. Now, for blood, it actually has a constant which is 15 drops per minute, and if it's for infusion, which is lighter infusion, is 20 drops per minute. So let's get started. So 500 mils of dextrosaline is to be given for 4 hours. The intravenous set delivers 20 drops per mil. Calculate the flow rate the infusion should drop per minute. So we're going to take out our parameters and work with the formula. So what are the parameters? The formula is drip rate is equals to total volume of infusion times drop factor divided by the total time of infusion. So the total volume of the infusion is 500 mils. So we'll take down the 500 mils. Then the drop factor is already given in the question, because the question states that 500 mils of dextrosaline is to be given for 4 hours. The intravenous set delivers 20 drops per mil. So I've already gotten our drop factor to be 20 drops per mil. So divided by the total time of infusion, and the total time of infusion given here is 4 hours, and we have to convert it to minutes. So what we are going to do is we're going to take these 4 hours and convert it to minutes, which will be 4 times 60. So let's proceed. 500 mils times 20 drops per minute. 500 times 20 will give us 10,000 divided by 4 times 60, which is 240, which sums up to be 41.67 drop per minute. And now we can't actually go with a decimal point, so we're going to round it off to be 42 drops per minute. So with the question given, which is 500 mils of dextrosaline is to be given for 4 hours, the intravenous set delivers 20 drops per mil. Calculate the rate of the infusion to drop per minute. The answer for that will be 42 drops per minute. So the rate of infusion will drop 42 drops per minute. So that is that for this question. So we're taking another question, which is a patient is placed on 10% dextrosaline, 1 liter to run for 12 hours. Calculate the flow, the drop per minute. So we're going to bring out the parameters, and then we're going to use this formula. So firstly, we're looking for the total volume of the infusion, which is 1 liter, because it says 10% dextrosaline, 1 liter to run for 12 hours. Then the total time taken for this infusion is 12 hours. And then the drop factor is actually not indicated in this question. So we're going to go with the constant, which is 20 drop per minute. Now, using the formula, we bring out our parameters, which is 1 liter, which is the total volume of infusion. And when we're converting liters to milliliter, it will be 1 times 1000, which equals to 1000 milliliters. So it's 1000 milliliters times the drop factor is 20 divided by the total time taken, which is 12 hours times 60, because we're actually calculating the time in minutes. So 1000 times 20 is going to give us 20,000. Then 12 times 60 will give us 720, which amounts to 27.78. And then because it is in decimal, we can't just leave it like that, because we are using the drop per minute to actually give the infusion. We're going to convert it to the nearest whole number, which will be 28 drops per minute. So a patient that is placed on 10% dextrose saline, 1 liter to run for 12 hours, the drop per minute or the drip rate is actually 28 drops per minute. Thank you for watching, and thank you for staying true to the end of this video. So do well to like and share this video, and also do well to comment in the comment section what you want us to do in our next video.